Welcome to Maths and Science by IITian channel. In this channel, in today's present lecture, I will be giving a lecture on calculus, and in that I will be talking about integration and how to find out the definite integral of a trigonometric function where the integral is calculated from 0 to infinity and the function x is sin to the power of 5x by x to the power of 5. Here the main crux of the problem is to find out the sin to the power of 5x. There are various methods to find out sin to the power of 5x. One is using the basic trigonometry, that is sin to the power of 5x is equal to sin x into sin to the power of 4x. Sin to the power of 5x is equal to sin x into sin to the power of 4x, and sin to the power of 4x can be multiplication of sin square x into sin square x, whereas sin square x can be converted into the form of cos 2x, and from there we will be able to simplify the integrand and we can integrate and solve the problem. That is from the basics of trigonometry. Another method is to use the complex number method. In complex number analysis, what we have learnt, which I have given many lectures on complex numbers, in complex numbers, if you go and see those lectures, you will understand that sin x is equal to e to the power of ix minus e to the power of minus ix whole divided by 2i. This is the formula from complex numbers we have got, so that we can directly find out sin to the power of 5x by expanding the right hand side using the binomial theorem. You can do it either way which is convenient to you, but I prefer going for the complex numbers. In this lecture, I prefer to do it through complex numbers and using binomial theorem instead of going into the traditional method. Let us try to learn something new. Now, this particular problem involves binomial theorem, complex numbers analysis, and expansion of sin to the power of 5x, and then integrating it and finding the value for the x value ranging from 0 to infinity. It is a definite integral. It is a very good example. This type of examples may be asked in the examinations regularly for CBSE, class 12, for JEE mains, JEE advanced, CSIR mathematics, or GATE engineering mathematics, or any higher level mathematics examination. Let us try to solve this particular example using complex numbers and binomial theorem. What is the question given here? Question is find integral 0 to infinity sin to the power of 5x by x to the power of 5 dx. Let's go for the solution. Please pay attention to it. We will be using the complex numbers and binomial theorem here. What is e to the power of ix minus e to the power of minus ix whole divided by 2i? This is equal to sin x. This is what is from basics of the complex numbers. Please remember this. Very important equation. Now, what will be the value of sin to the power of 5x is equal to the left hand side to the power of 5. That is e to the power of ix minus e to the power of minus ix divided by 2i to the power of 5. And what will be the value of denominator? 2 to the power of I to the power of 5 is equal to 2 to the power of 5 into I to the power of 5. That is equal to 32 into I to the power of 4 into I. What is the value of I to the power of 4? It is unity. 32. These are also I have explained in my previous lectures. Please see them. This will be 32i. That means this will be 1 by 32i into e to the power of ix minus e to the power of minus ix to the power of 5. Now, we are only concerned about finding a minus b to the power of some n using binomial theorem. Please try to understand the binomial theorem. It's a very important theorem in mathematics. It has got lot of applications, and binomial expansion is very handy, and it's got lot of applications in engineering, mathematics and sciences. What is a plus b to the power of n? From binomial expansion it will be a to the power of n plus nc1. From permutations and combinations, what is ncr? That is equal to factorial n by factorial n minus r into factorial r. This is a very important formula. You please remember from permutations and combinations. Now nc1 is factorial n divided by factorial n minus 1 into factorial 1. What is the value of factorial 0? Factorial 0 is equal to 1, factorial 1 is equal to 1. There are many videos made by me on factorials and finding from number theory, the factorial approximations, gamma functions, beta functions. Please see them for further understanding. nc1 into a to the power of n minus 1 into b to the power of 1 plus nc2 into a to the power of n minus 2 into b to the power of 2 plus like this it will go on up to b to the power of n. Now, here what we are supposed to find out? E to the power of ix minus e to the power of minus ix. It's very simple once you know the binomial theorem formula. What is binomial theorem formula says? e to the power of ix whole to the power of 5. Because it is minus here, we will be alternatively using plus and minus as per the given equation, or else you can use the plus sign and put minus in the brackets. This will be minus nc1, that means 5c1 into what is a? This value let us say a, and this value let us say b, e to the power of ix to the power of 5 minus 1 into e to the power of minus ix plus 5c2 into e to the power of ix to the power of minus 5 minus 3, 5 minus 2, sorry, into e to the power of minus ix whole square minus 5c3 e to the power of ix to the power of 5 minus 3 into e to the power of minus ix whole square plus up to minus 1 to the power of 5 into e to the power of minus ix whole to the power of 5. When you simplify and find out, what will be its value? This value will be equal to e to the power of ix to the power of 5 is e to the power of I to the power of 5 and x to the power of 5. Similarly, you just see. What is the value of first term? Let us write e to the power of I into 5x. What will be the second term? Minus 5 factorial 5 divided by factorial 5 minus 1 into factorial 1 into e to the power of I 4x. E to the power of ix to the power of 4. What happens? Into e to the power of minus ix. What will be third value? Plus into factorial 5 by factorial 5 minus 2 and factorial 2 into e to the power of 3ix, I 3x and e to the power of minus I 2x and so on. What will be the values? E to the power of I into 5x minus factorial 5 by factorial 4 is 5, 5 by factorial 1 is 1. This will be 5 into e to the power of I 4x minus ix. That will be 4 minus 1 is 3. We are simplifying here. I 3x plus factorial 5 by factorial 3 will be 5 into 4 is 20. 20 divided by factorial 2 is 2. That is 10. This value will be 10. And e to the power of I 3x minus e to the power of I 2x will be e to the power of ix minus 10 into e to the power of minus ix. It is nothing but a mirror image of the other positive values, mirror image of the negative mirror image, plus 5 into e to the power of minus I 3x minus e to the power of minus I 5x. This is the value what we have got. It's a very simple mechanical way of expressing a plus b to the power of n. You remember that formula? From that you can easily find out e to the power of ix minus e to the power of minus ix to the power of 5. Ultimately, this will be equal to e to the power of I into 5x minus e to the power of minus I into 5x. This is 1. Minus 5 into e to the power of I 3x minus e to the power of minus I 3x. We are only just rearranging the values, plus 10 into e to the power of ix minus e to the power of minus ix. From the basics, we know that e to the power of ix minus e to the power of minus ix divided by 2i is equal to sin x, which we are aware. This formula we have already noted in the beginning of the lecture itself. From this, we can say if x is replaced by some theta, x is equal to m theta. Please understand this concept clearly. What happens? E to the power of I m theta minus e to the power of minus I m theta whole divided by 2i is equal to sin m theta. Very powerful equation. A theta is any value, we can say even. From this we can even say, we have only assumed and done this, we can even say e to the power of I nx minus e to the power of minus I nx divided by 2I is equal to sin nx. This is the most important formula which we will be regularly using in engineering applications, science applications and mathematics applications. Whatever concepts I am clearing here are very, very important. Now, with this, what is that we have got? Now, e to the power of I 5x, I into 5x minus e to the power of minus I into 5x can be written as 2I into sin 5x. Similarly, e to the power of I 3x minus e to the power of minus I 3x, this can be written as 2I into sin 3x. Similarly, e to the power of ix minus e to the power of minus ix, this can be written as 2I into sin x. These three values we will substitute in this equation. Now we have got the value of therefore, please pay attention for each and every step. Therefore, e to the power of ix minus e to the power of minus ix to the power of 5 is equal to how much? E to the power of 5x minus e to the power of minus 5x, it is nothing but 2I into sin 5x. First value. Second value, minus 5 into minus 5 into 2I into sin 3x. Next is plus 10 into sin x. Plus 10 into 2I into. Now, what is the value of sin to the power of 5x? That is equal to e to the power of ix minus e to the power of minus ix whole divided by 2I to the power of 5, that is equal to 1 by 32I into e to the power of ix minus e to the power of minus ix, which implies we will replace the above value in e to the power of ix minus e to the power of ix to the power of 5. That implies that is equal to 1 by 32I into 2I is common in the above value, we will take out 2i into sin 5x minus five sin 3x plus 10 sin x. When you divide 2i with 2i 32i, it will be 16. 2i get cancelled, 16 will be the answer. That is equal to 1 by 16 into sin 5x minus 5 into sin 3x plus 10 into sin x. This is the value of sin to the power of 5x. Now 90% of your problem is solved now. Now what we have to do is, it is a ordinary simple integral. We will find out that value very easily. What is the integrand? What we have to find out? Integral 0 to infinity sin to the power of 5x by x to the power of 5 dx we have to find out. That will be integral 0 to infinity. What is sin to the power of x? That is 1 by 16. We will take it common. In the numerator it will be sin 5x minus 5 into sin 3x plus 10 into sin x whole divided by x to the power of 5 dx. Now the problem becomes very easy. You take out 1 by 16 and integral 0 to infinity we will write, expand it, sin five x by x to the power of 5 minus 5 into sin 3x by x to the power of 5 plus 10 sin x by x to the power of 5 dx. We will integrate separately each and every part. Denominator for all of them is x to the power of 5. And you use one important concept. That is 0 to infinity function x divided by x to the power of 5 dx. Let it be x to the power of p also. It gets decayed very fast. It will be 1 by 24 into integral 0 to infinity function fourth derivative of function x by x dx. This is one shortcut to find out the values of each and every individual values. And another also you can use fourth derivative of d4 by dx4 of sin kx, because we are using here sin 5x, sin 3x. The problem can be of any type in the examination. It need not be sin to the power of 5, sin 5x. It can be anything, sin kx. Then it will be k to the power of 4 into sin kx, if it is the fourth derivative. If it is using these two, we get that integrand I is equal to 1 by 16 is already there. Integrand is equal to, this is equal to I, let me call it. I is equal to 1 by 16 into 1 by 24 into 0 to infinity what is the value here? Ten sin x, or we can even say 5 to the power k to the power of 4. Hence 5 to the power of 4 into sin 5x minus 5 into 3 to the power of 4 into sin 3x plus 10 into 1 to the power of 4 into sin x. We have used these two shortcuts, whole divided by x dx, because integral of fx by x to the power of 5 dx is equal to 1 by 24 into fourth derivative of function x, which we have found here, divided by x dx. Now, we know very well the standard integral value. Integral, it is also very important, 0 to infinity sin kx by x dx is equal to pi by 2. We know very well this is integral 0 to infinity sin x by x is equal to 1. That is not 1, it is pi by 2. Now, by substituting this value in the above equation, we will get I is equal to 1 by 16 into 24 into integral 0 to infinity 5 to the power of 4 is a constant into sin 5x by x dx is pi by 2. Minus 5 into 3 to the power of 4. 5 into 3 to the power of 4 is 3 into 3, 9, 9 into 9 is 81. 5 into 3 to the power of 4 into pi by 2 plus 10 into 1 into pi by 2. This value will be 1 by 16 into 24 into pi by 2 into 5 to the power of 4 is 625 minus 5 into 81 is equal to 5 into 81. 8 is 400, 405 plus 10. That is equal to pi by 2 into 1 by 16 into 24 into 625 minus 405. How much it is? 220. 220 plus 10 is 230. Then this answer will be pi by 2 into 1 by 16 into 1 by 24 into 230. Now 230 can be divided by 2. This 2 will go here, it will be 115. Hence the answer will be 115 pi divided by 16 into 24. What is the value of 16 into 24? 16 4 is 64, 16 2 is 32, 32 plus 6 384. That means integral 0 to infinity sin to the power of 5x divided by x to the power of 5 dx is equal to 115 by 384 into pi. This is the final answer. Even though I have gone little bit slow here, only the reason being I want to explain binomial theorem and I wanted to explain complex numbers usage, complex numbers and analysis, and I wanted to explain trigonometric functions. And some shortcuts of definite integration. Now, with this, we got the answer as 115 by 384 into pi. It's a very good example. It's an exhaustive example, so that it's very good for practicing. And if you have any queries, you please put in the comments column. I will explain you. And with this I want to conclude this lecture. And if there is a value addition because of this lecture to you, kindly share and subscribe to my channel. Maths and Science by IITian. Learn it slow, learn it perfectly, learn the concepts clearly so that you can apply them fast in the examination. While learning, don't jump at a faster pace. You try to learn the concepts clearly with patience. Best of luck to everybody. Thank you for listening to me. Thank you for seeing my lecture. Best of luck to you. Kindly share and subscribe to my channel Maths and Science by IITian. I will be bringing this type of typical problems to you often, and best of luck to everybody.